Good morning, sir. Today's my tech talk topic is on monolithic 3D integration. Here we have coming to the topic. What is monolithic 3D integration? Here, monolithic or sequential 3D integration is nothing but it is a powerful technology enables for actual 3D IC design as stacked layers can be connected at the transistor scale. And this paper review is like the opportunity is got by MCT and highlights the application benefiting from this small 3D contact fish. Okay, and here when we connect these transistor scales through the 3D IC design, and we have will gain our integrate sequential integration like it is a powerful technology enables for actual 3D IC design as the stack layer can be connected at the transistor scale. And this paper review that opportunity bought by M3DI and highlights the application benefiting from these small 3D contact pitch. And your demonstration coming to the demonstration of Japan. There there was demonstrated on monolithic 3D integration in 1983 to 2005. So these 3D ICs were first successful demonstration in 1980 by Japan, where research and developed 3D ICs was initiated in 1981 with the three-dimensional circuit elements and R&D project, and this by the Research and Development Association for future new electron devices. They were initially two forms of 3D ICs designed being invertigated or recrystallization and wafer bonding with the earlier success demonstration using crystallization. Okay. And this year, in the year 1980, the Japan demonstrated very successfully and they were developed very crucially. And this, with the help of this three-dimensional elements, R&D project, it was developed a huge of association for the future new ADC electronic devices transistors, resistors, all the equipments which will comes under this ED like electron devices. And in October 1983, a fugitive research team including Kawamura and Robio Sasaki and T. Ilgani successfully fabricated a three-dimensional complementary metal oxide. We have seen many metal oxides complementary dimensional metal oxide, and it is shortcutly named as CMOS integrated circuits, and these are mainly used in laser beam decrystallization, and it consisted of a structure in which one type of transistor is fabricated directly above a transistor of the opposite type with separate gas and all the insulators in between be connected in between, and this crystallization structure is nothing but like uh, which is fabricated directly above the transistor of the opposite type with separate gates and an insulator in between the both transistors, and this was successfully fabricated in three-dimensional complementary metal oxide in the year 1983. Coming to manufacturing technologies for 3D SSS, there are several methods for 3D like uh, 3D IC design, including recrystallization and wafer bonding methods. There are two major types of wafer bonding. C is copper to copper connections, copper to copper connection between the stacked ICs used in TSVS, and through silicon via TSV. As of 2014, a number of memory products such as high bandwidth memory and hybrid memory cube have been launched that implement 3D IC stacking with TSVs. And these kind of manufacturing technologies for 3D SSDs was developed in including this crystallization and wafer bonding methods. And, there are two major types of wafer bonding robotic copper. And this kind of manufacturing technologies for 3D ICs. And there are a number of key stacking approaches between implemented and exploded. This includes die-to-die or die-to-wafer and wafer-to-wafer methods. These are the methods including this 3D integration, monolithic 3D integration. Like we have process where temperature limitations are addressed by partitioning the transistor fabrication into two phases, like AI temperature phase, which is done before layer transfer, followed by a layer transfer using ion pair, also known as layer transfer, which has been used to produce silicon on insulator, like wafer for the past 2 decades. And all are well known about this process temperature limitation and by the partitioning of the transistor fabrication into two phases. And it has temperature phase, which is done before layer transfer, followed by a layer transfer using ion curve, and also known as a layer transfer. And it has been used to produce silicon on insulated SOI wafer for the past 2 decades. And coming to die method, like we have electrons compounds are built on multiple die which are then aligned like and bonded. We have the tanning and TSV may be done before or after bonding. Like one advantage of die to die is that each component die can be tested first, so that one bad die does not ruin or interstack. And moreover, each die in the 3D IC can be bind before and so that they can be mixed and matched to optimize power consumption and performance. Coming to die to wafer method, electronic components are built on two semiconductor wafers. Like on wafer is decided the singulated dies or aligned and bonded on die sides of the second. And as in the wafer on the wafer method, finding and TS equation are performed either before or after. And these additional die may be added to the stacks before dies. Like as you know, well, electronic components are built on two semiconductor wafers. One wafer is built or dies. The singulated dies are aligned or bonded onto die sides of the second wafer. As in the wafer on the wafer method, this thing timing and de-acidification are performed by the before or after bonding. Additional die may be added to the stacks before dicing. And these are and coming to wafer method, electronic components are built on two or more semiconductor wafers, which are then aligned and bonded and decided into three dices. And each wafer may be timed like before or after bonding. Vertical connections are either built into the wafer before bonding or else created in the stack after bonding. And we have there many these through silicon vias, like TSV is passed through the silicon substrate between active layers or between an active layer and internal bond pad. Coming to circuit security, that's 3D integration. You can achieve security through accuracy and stacked structure complements. Attempts to reserve entering the circuitry and the sensitive circuits may also be divided among the layers in such a way as to cure the function of each layer. And moreover, 3D integration allows to integrate decided system monitors like a feature in separate layers. and we have more circuits to divide it among the layers in such a way as to occur the function of each layer. And coming to bandwidth, 3D integration allows large number of vertical layers between the layers. This allows construction of wide bandwidth buses between functional blocks in different layers. A typical example would be a processor like a plus memory 3D stack with the cache memory stack on top of the processor. And coming monolithic applications. A monolithic application is self-contained and independent from other computing applications. The design philosophy is they take that like application is responsible not just for a particular task, but can perform various steps needed to complete a particular function. And nowadays, some personal financial applications are monolithic in the sense that they help the user carry out of a complete task end to end, and private data cell phones or many these financially applicated, and then parts of the large system of application that works together. And thank you.